chemical equation is an equality between the reactants and the products. So you can think of the arrow as an equal sign. So we have 2 sodiums plus 1 chlorine goes to make 2 sodium chloride. In our chemical equation, I'm going to pause the video and see how many of these 6 you can get correct. Restart when you have an answer. So what you start with on the left side of the arrow are called reactants. You produce products. So the sodium chloride is your product, and the arrow is a yield or equal sign. The little number, when we did naming, we talked about those. Those were our subscripts. When you have a balanced equation, you never change the subscripts. You're going to add coefficients, which are the numbers in front, to make both sides equal. And this S, G, and S are state symbols. They're telling you what state of matter that substance is currently at. So for your state symbols, S represents solid, L is a liquid. That's a true liquid, as in we melted something and it turned into a liquid. G is gas, and AQ is aqueous solution. That's what we deal with the most in chemistry because we dissolve solids in water, they dissolve, and we have an aqueous solution. The law of conservation of mass states that matter cannot be created nor destroyed. It can only change forms. In other words, the mass of the reactants and the products have to equal each other. So if I start with 10 grams of mercury oxide and I heat that up and I have less than 10 grams, I only have 9.3 grams, I must have given off some of that mass as a gas. 0.7 grams to be exact, because those two have to add up to the 10 grams that I started with. So if it looks like you added or lost mass, if you added mass, a gas from the atmosphere must have combined with your substance. If you lost gas, or if you lost mass, you must have lost a gas to the atmosphere, which is no longer being weighed. To test this hypothesis, you can always do it in a closed container, the reaction, and the mass should be the same before and after. Some types of problems that you could see are like this one. When you have 127 grams of copper reacting with 32 grams of oxygen, and no copper is left over, how much copper 2 oxide is produced? So if we don't have any of our reactants left over, then we can just say 127, this one's 32, and this is X. Bring down your plus sign, bring down your equal sign, and solve for X. So that would be 159 grams. The coefficients will not make a difference. You're just adding and subtracting. In this case, we just needed to add. If we have 10 grams of a substance and we heated that in a test tube, and then we cooled it and weighed it again, and it weighed less than 10 grams, it only weighed 4.8 grams, was mass conserved, yes or no? You should have said yes, mass was conserved, but it doesn't look like mass is conserved because we must have lost it as a gas. So yes, but a gas must have been produced, which left the container. If done in a sealed container, the mass should have stayed 10 grams. But mass must always be conserved. Whether we see that conservation or not is a different issue, but mass is always conserved. A balanced equation follows the law of conservation of mass. Before we can get to balancing an equation, we're going to have to be able to count atoms and then count atoms with coefficients. So the first one, we have a subscript 2. This 2 only goes to what's directly attached to it, which would be the hydrogen. So we have 2 hydrogens and 1 oxygen. When you have parentheses, then that subscript will go to everything in the parentheses. So we have 1 aluminum because the 3 is not attached to aluminum. And then 1 times 3 is 3 oxygen, and 1 times 3 is 3 hydrogens. Go ahead and pause the video and do the next 2 on your own. Restart when you have your answers. So you should have had 1 aluminum and 3 chlorine, and 3 potassium, 1 phosphorus, and 4 oxygen. Go ahead and pause the video and do these 4. Restart when you have an answer. So 3 calcium, 1 times 2, 2 phosphorus, 4 times 2, 8 oxygen. 1 silver, 1 nitrogen, 3 oxygen. 1 carbon, 2 oxygen. 2 sodium, 1 sulfur, 4 oxygen. And that's why when we did formula writing, it was so important that you put parentheses around your polyatomic ions if you had more than one of them. So a coefficient is a multiplier. It's always a whole number, or at least in all of your cases, you'll see whole numbers, and it's found in front of the compound. So if I have 3 molecules of calcium fluoride, that's like having 1, 2, 3 molecules of calcium fluoride. So that 3 in front is multiplying. Without having to write it out each time to visualize it, you can say 3 times 1 is 3 calcium, and 3 times 2 is 6 fluorine. Notice 3 calcium, 6 fluorine. Let's look at 2 more examples. So these are our same compounds we had a minute ago, but now they have coefficients. So 3 times 2 is 6 hydrogen, and 3 times 1 is 3 oxygen. The parentheses are a little bit more complicated. If you get confused, you can always ignore the coefficient, figure out how many you have, and then multiply that by the coefficient. Or you can say I've got 4 aluminum. I have 1 times 3, which is 3, times 4, oxygen, and 1 times 3, which is 3, times 4, 12 hydrogens. Go ahead and try the next 2 on your own. Restart when you have those done. So you should have gotten 2 aluminum and 6 chlorine, 6 potassium, 2 phosphorus, 8 oxygen. I'm going to pause the video, do these 4 on your own, restart when you have those 4. 2 times 3 is 6 calcium. 2 times 2 is 4 phosphorus. 4 times 2 is 8, times 2 is 16 oxygen. 5 silver, 5 nitrogen, 15 oxygen. 3 carbon, 6 oxygen. 8 sodium, 4 sulfur, and 16 oxygen. All right, now we're ready to balance an equation. Before we can balance, though, we may have to write an equation. Some equations will be given and you just balance it. Some you'll have to go from words to the equation and then balance. So this first one, we have to write our equation. So it says that we have a solid piece of zinc reacts with hydrochloric acid. So a solid piece of zinc. We're going to write Zn, and then we check, because that's a solid all by itself, is it one of the 7 that can't be up by itself? There's zinc, so yes, it's not diatomic, it's fine. Since they gave us the state symbol of a solid, we can go ahead and put that there. That'll be really important at the end of this chapter. Plus hydrochloric acid, hydro, it came from I, so hydrochloric acid is HCl. And your acids are always going to be aqueous because they're solutions. To produce. To produce is our arrow, as we're producing a solution of zinc chloride and hydrogen gas. So zinc chloride, zinc's a +2, chlorine's a -1. So those go together like so. And it says a solution is AQ plus hydrogen gas. So hydrogen, we check, is hydrogen one of the 7? It is one of the 7 diatomics, so we have to have 2 of them, and it's a gas. So that's our skeleton equation. Skeleton equation just simply means the unbalanced equation. But it is correct charges. I did have to have 1 zinc and 2 chlorines because that's how they go together. So when I say you don't have to balance something, you do have to put correct charges and write correct formulas. You would just be giving me the skeleton equation, which is what we have written here. We can now take this skeleton equation and balance it. So the state symbols have nothing to do with how we balance our equation. So I've omitted them on here just for simplicity's sake. So what it means to have a balanced equation is currently I have 1 zinc. I have 1 hydrogen, and that hydrogen is bonded to 1 chlorine. On the product side, I have 1 zinc bonded to 2 chlorines and 2 hydrogens bonded to each other. Notice I do not have equal atoms on both sides. This is an unbalanced equation. In order for it to be balanced, I have to have equal zinc, equal hydrogen, and equal chlorine on both sides. I can only fix the issue by adding coefficients to the front of each number. So notice that I have 2 chlorine on this side, 1 chlorine over there. There's no rules to balancing equations on what you have to start with, but generally you leave hydrogen and oxygen to the end because a lot of times those are in multiple places. So to fix my hydrogen or my chlorine, I have 2 chlorine, so I'm going to put a 2 there. When I put a 2 there, it doesn't just change my chlorines, it also changes my hydrogen because they're bonded together. So now I have 2 hydrogens and 2 chlorines. So looking at my equation, I have equal atoms on both sides. Sometimes when fixing one element, you mess up another element. You have to keep going, kind of like a puzzle, until you have equal atoms on both sides. So the way that this could be asked on a test is I could either say, what's the coefficient in front of zinc chloride when this equation is balanced? And your answer choices are 0, 1, 2, 3. This is not a 0. Any blanks are always 1s. Because I do have 1 zinc chloride, you never have a coefficient of 0. So 0 is always the wrong answer. You can also have what's the sum of the coefficients when this equation is balanced. The sum of the coefficients would be 5, because 1 plus 2 plus 1 plus 1 gives me a coefficient sum of 5. And finally, you could see answer choices that look like so. That's just saying that this is the first blank. This would be the second blank. So A would be our correct answer. So those are a couple different ways you could see it on multiple choice. For response, it would just be balance this equation. Go ahead and pause the video and write the skeleton equation for this reaction. Do not try balancing it until you've checked your skeleton equation. Restart when you have that equation. That's what you should have gotten, because water, if it just says water, would be a liquid. If it said ice, solid, or water vapor, would be a gas. But water can never be aqueous because water is never dissolved in water. All right, so now we need to balance this equation. We don't want to draw those particle diagrams every time we're trying to balance an equation because that would get very tedious very quickly. So the easiest way to balance it and still have a visual is to list all of our elements out. So we have hydrogen, we have P, we have oxygen, we have sodium. Those are the elements that we have on both sides. Notice that I did this under the arrow so I can easily keep the reactants and product amounts separate. You can do it elsewhere on your paper if you don't have room, but it's always nice to do it underneath the arrow. So now I'm going to add up how many I have. I have 3 hydrogens plus 1 gives me 4. 1 P, 4 oxygen plus 1 gives me 5, and 1 sodium. On the product side, I have 2 hydrogen, 1 P, 4 plus 1, or 5 oxygen, and 3 sodium. Remember we said it doesn't matter which one you start with, but we usually leave hydrogen and oxygen to the end. Notice hydrogen we have in 3 out of the 4 spots, so that's why we usually leave it to the end. I'm going to fix my sodium first, so I can follow that rule. And I have 3 sodium on the product side, so I need 3 on the reactants. So looking at my balanced equation, I need to put a 3 here, so that way I can have 3 sodium. Notice I change it in the balanced equation first, and then I change it down here so I don't forget. Sometimes people try to change it on their work, and then they forget to even put the number in the equation, which was the whole point. So first we put the 3 for sodium, but that's not the only thing that got changed. Our oxygen also got changed. We have 4 plus now 3 gives me 7. And I have 3 plus now 3, or 6 hydrogen. So hydrogen and oxygen are messed up. Everything else is good. So out of those two, hydrogen is the easier one to fix because oxygen's in everything. And hydrogen, I need more on the product side. And I only have hydrogen in 1 spot on the product side. So something times 2 needs to give me 6. So that's going to be a 3. So 3 times 2 gives me 6. And then for my oxygen, I have 4 plus 3 gives me 7. Notice that everything is now the same. Always double check that you didn't mess up somewhere and you do actually have equal amounts. And you can either leave phosphoric acid and sodium phosphate blank, or if you want, you can put 1s there. One last thing before moving on is if you mess up and get too big of numbers, if you've gotten 2, 6, 2, 6, notice all of those are reduced by 2, which we would get 1, 3, 1, 3. If you can reduce it, you have to reduce it. Be careful though, if you have any of them that are blank, if that one was blank, let's say it was 2, 6, blank 6, then you have a 1. And if you have a 1 anywhere, then you can't reduce it. But if it can be reduced and you do not reduce it, it is wrong. Because balancing is always balancing with the lowest coefficients possible. I'm going to pause the video and try writing your skeleton equation for this one, restarting when you have your skeleton equation. That's what you should have gotten. Chlorine should be a gas. Lithium iodide, aqueous, because it said a solution. Lithium chloride is also a solution, so aqueous. And iodine is a gas. Your chlorine and iodine should have 2s with them because both of them were diatomic. Remember the 7 that can't stand alone. They start at 7 and make a 7. And there's 7 of them. So notice that chlorine and iodine, both of them needed 2 for that reason. So now we're going to list out our elements. We have 2 chlorine, 1 lithium, 1 iodine. On the product side, we have 1 chlorine, 1 lithium, 2 iodine. So it doesn't matter which one I fix. I'll go and fix my chlorine first. I have 2 on this side. I need 2 on the products. I put a 2 here. 2 times 1 is 2. And I have 2 lithium now. So now my lithium and my iodine are messed up. So if I need 2 lithium on the reactant side, I can put a 2 here. 2 lithium, 2 iodide. So that is your balanced equation. All right, go ahead and pause the video. Try writing this skeleton equation on your own. Restart when you have your answer. So you should have gotten that silver nitrate was AgNO3 and it's aqueous because it's a solution. Barium chloride, BaCl2, is aqueous. Silver chloride was a precipitate. Remember back in our matter unit, we said when 2 liquids or aqueous solutions are mixed and a solid drops to the bottom, that solid is a precipitate. That's what we were doing here. 2 aqueous solutions making a solid. That solid is silver chloride. And barium nitrate should be aqueous. Make sure that all of your charges canceled out like so. Go ahead and try balancing this equation, restarting when you have an answer. So on this one, you could have listed out all your elements and did silver, nitrogen, oxygen, barium, and chlorine. But one trick that may help you balance things quicker, especially on something like this that has multiple elements, is notice you have NO3, which is a polyatomic ion, on both sides. That's the only place we have nitrogen and oxygen, so we can keep nitrate together. So we can say that we have silver, nitrate, barium, and chlorine. We had 1 silver, 1 nitrate, 1 barium, 2 chlorine. 1 silver, 2 nitrates, 1 barium, 1 chlorine. So notice we have a 2 for that entire thing, which is nitrate. So looking at it, it's much cleaner than if we had listed all our elements out. And we can see that our nitrates are messed up and our chlorines. If I want to fix nitrate, I just need to put a 2 here. It's going to give me 2 silver and 2 nitrates. So now my silver and my chlorine are messed up. But I can just put a 2 here, 2 silver, 2 chlorine. Notice that now it's balanced, and that's probably much easier than listing out all of our elements.